Hello, in this session I want to go over Introduction to Probability, and this material is based on this chapter 2 of the Jayes et al. Book. Alright, so now the Jayes et al. Book is available. It's an open intro statistics book which is accessible for free from the link that's posted in the syllabus. Okay, so chapter 2 is probability, and let's go over different aspects of probability and how to compute probability and so on. So probability of an outcome is defined as the proportion of times the outcome would occur if we observed the random process an infinite number of times. So probability of getting heads in a fair coin toss would be, in the long run, it will be 0.5. If you toss a coin 100 times, the number of heads you will get may not be 50. It may approximately be 50, but if you do it like many times over, then the probability will converge towards 0.5. Similarly, if you have a die that's got six sides, and if it is a fair die, and the probability of you rolling a 4 would be 1/6. There are 6 sides, and each side has equal probability of coming up, and so probability of rolling a 4 would be 1/6. Now, probability is defined as a fraction, and you can use 1/6 or maybe as a decimal. When you talk about events, there are some events called disjoint events. When you have a disjoint event, that means the outcomes cannot both happen at the same time. Say, for example, rolling a 4 cannot also happen rolling a 2. These are two disjoint events. Okay, and so if you want to find the probability of rolling a 4 or rolling a 2, probability of rolling a 4 or rolling a 2 is computed as the probability of rolling a 4 plus probability of rolling a 2. So in other words, it will be 1/6 plus 1/6 equals 1/3. As a general rule, you could calculate the probability of disjoint events simply by adding up the probabilities of individual events happening. As long as there is nothing common between those two events, then you can simply add up the probabilities. So probability of A or B, A1 or A2, is given as a probability of A1 plus probability of A2. And if you have many outcomes that are all disjoint, there's nothing common between them, then you can simply add up their probabilities to calculate the overall probability. Alright. Now sometimes there is another rule that you can apply. That is, if there are two events A and B, whether they are disjoint or not, then the probability that at least one of them will occur, A or B, is given as probability of A plus probability of B, and from that you subtract probability of both A and B happening. Now if the events are disjoint, then the third part of the right hand side will become 0, so that will become your previous slide. If it is not a disjoint event, then probability of A and B happening at the same time, if it is non-zero, then you can include that in the equation 2.15. And probability of A or B is given as probability of A plus probability of B minus probability of A and B. A complement rule is when you have an event A happening is given to you, and the probability of event not happening, that is the complement, or AC, and it is probability of event not happening is 1 minus probability of the event happening. So probability of A complement equals 1 minus probability of A, or probability of A is 1 minus probability of A complement. Now if you have independent events, then the probability calculations would use a multiplication rule. If you have two processes that are independent, that is, if knowing outcome of one provides no information about the outcome of other, then these processes are known to be independent. For example, if you toss a coin, flip 3 times, if you flip a coin 3 times, then knowing whether you get head the first time will not affect what you're going to get the second and third time. So the flips are independent. The outcomes of the flips are independent. So if you have independent events, then probability of those two independent events occurring at the same time, A and B, is simply product of A times product of B. So multiplication rule is if you have two events that are independent, and probability of both happening is probability of the first event happening times the probability of the second event happening. Alright, next we go on to a concept called marginal and joint probabilities. Now take a look at this contingency table. This table lists 792 observations, and these observations are classified based on whether the parents of a teenager have attended college or not attended college. So parents degree meaning parents got college degree, parents not means parents did not get college degree. And the total number of observations 792. Of this, 231 observations or when the teen got a college degree and the parent also got college degree, and 214 observations is when the teen got college degree and the parents did not get college degree, and so on. So this is a contingency table, 2 by 2 contingency table, and the column totals here, for example, under parents degree 231 plus 49, that means 280 parents got college degree out of a total of 792, and 512 parents did not get college degree out of 792. The row totals, on the other hand, talk about the teen getting college degree or not. So teen getting college degree 445 times out of 792, and 347 445 times out of 792 is the number of times the teen got college degree, and 347 out of 792 is the number of times the teen did not get college degree. So that's called a contingency table. And when you have a table like this, the margins, that is the totals that you have, you can use those to calculate marginal probabilities. Okay, say for example, a teen attended college or not. The teen attended college, probability of teen attended college would be, if you look at the row, college is 445 for teen, and the teen attended college is 445. Probability of teen attended college is 445 over the total number of observations 792. And similarly, you can also calculate the marginal probability of parent not attending college, and parent not is 512, and total number of observations 792. So probability of parent not attending is 512 over 792. These are called marginal probabilities because they kind of use the number from the margins. Then you have what are called joint probabilities. In joint probability, you are interested in the individual cell values and one of the column or row values. Say for example, this one says probability of teen attended college given the parent attended college. What is the probability of that? Okay, probability that the teen attended college given, so this vertical bar means given parent attended college. Now probability of teen attended college would be, and you only want to, so the second part of this left hand side tells you which column to look at. So parent college is the column I want to look at. So in this case it is 231, 49, 280, this particular column. And so 280 is the total number of observations when the parents attended college, and of those, how many observations is where teen attended college? So it'll be 231. So 231 over 280 is the joint probability. So probability of teen attended college given the parent attended college is 231 over 280. Similarly, if you want to calculate the probability of teen attended college and parent not attended college, you look at the parent not column. You look at the parent not column, which in this case is 512 is the total, and the probability of teen attended college is 214. So probability of teen attended college over given parent not attended is 214 over 512. You can also look at another way. What is the probability of parent attended college given the teen did not attend college? So in this case, the teen did not attend college. You want to look at the row total for teen not, which is 347. So that goes to the denominator. And parent attended college, in that row, you want to find out the parent attended college would be 49. So probability of parent attended college when the teen did not attend college is 49 over 347. These are called joint probabilities. So if you have a contingency table like this, you can use this logic to calculate marginal probabilities and joint probabilities. Okay, next we have a concept called conditional probability, and well, the concept of marginal probability and joint probabilities can be used in calculating conditional probability. So the description that I had here, probability of teen attended college given that parent attended college, that is called conditional probability. And to calculate that, you simply use this formula. Probability of A given B is the same as probability of A and B over probability of B. So if I'm interested in calculating the probability of teen attended college given parent attended college, then look at probability of teen attended college and parent attended college. So the numerator is highlighted, probability of teen college and parent college, divided by probability of B, which is probability of parent college. Okay, the top part, probability of teen attended college and parent attended college, you can see from the previous slide. Both attended college is 231, is the number of times both teen and parents attended college out of a total of 792. So the numerator is 231 out of 792. The denominator, probability of B, which is probability of parent attended college, would be parent attended college is 280 and the total number of observations 792. So the value is 280 over 792. Now if you simplify it, you get 231 over 280. Okay, so that's how you calculate conditional probability. Okay. All right. So that's the end of this presentation on probability. There are a few more sections in chapter 2 of the Dees et al. Book, but we're not going to go over that right now, maybe a little later. Thank you.